Hello, one. So we have number 8 from 12a. So we have a pentagon ABCD is inscribed in a circle, and then B, C, and CD are 30 degrees. A, C, and B, D are intersect at a point F, and AB is 9 and AD is 24. What is BF? So we don't really have anything other than the word stuff. So let's make a diagram to see how they are related. And I'll have a 5 points. So let's say this is 1, 2, 3, 4. So it doesn't say they're equally spaced, but since I don't have much yet, so I'm going to just draw it that way. So that should be C, D, and E. Okay, so the BEC is given. So like B, E, C, this is 30 degrees. And then CED, so that's CE right here. And then D is right here. Okay, so that is gonna given 30 degrees. And then the AC, which is something like this, and BD intersecting at a point F. Okay, and then we are looking for BF, which is this piece. Okay, so that's the question mark. AD is also given. Oh my goodness, like this, the given information somehow really not really close to each other. So okay, this is AD, and then AB is also given. So this is 9, and then this is 24. Okay, so since you know the angle 30 degrees inscribed angle that is like subtended by this arc BC, but the angle right here is also subtended by the same arc, so they are facing towards the same arc, so that has to be same measure. And the same idea, 30 degrees subtended by the arc DC, and then this angle right here is also subtended by the arc DC, so this has to be 30 degrees as well. So, and then we want to find the BF. And I think we see it right now, so the angle 30 degrees are, it's like equal, so that means A to C is actually angle bisector in ABD. So we can just say 9 to 24 is like 3 to 8. So that ratio has to be the same. So if I want to say this is 3x, then that should be 8x. So which makes sense because it looks like 11 in total. All the denominators are 11, so that's kind of promising. And right now we want to know the BF, right? So there are a couple ways we can do at this point. We can take this ABD, maybe draw it separately, and then ignore the middle segments, and then maybe make a right triangle by dropping altitude from B to AD, because that is a 60 degrees. You can use that to get the other two legs. And then you can use the Pythagorean to get the entire hypotenuse, which will give you BD, so you can get the BF easily. But instead of doing it that way, because the numbers are not too nice, I like to use the log cosine because that looks like a good job for log cosine. If I want to say BD squared, okay, is equal to AB squared plus AD squared minus 2 times 9 times 24 times cosine 60. So if I solve this equation, I should be able to get BD. So that is 81. And then this is 24 times 24, but I don't want to write this as 576 here. And then you got 24 here as well. So that's why actually I didn't do that. And then this is like cosine root like 6 degrees, something we should know. But if I don't know, we can always use 36 90 triangles or the unit circle to get that value. So let's say this is 60. So that should be root 3. And that is 2. And this is 1. Cosine will be 1 over 2, right? So that should be 1 over 2. And that was 18 as well. So I just so that will give us 9 times 24. But this was 24 times 24. If I subtract 9 from 24, so I will get 81 plus, so 1524, right? Okay, so then I think the rest is kind of easier. If I multiply 15 by 20, that's going to be 300. So 4 15 is 60. So that will be 360. If I add 81, so that should be 441. And which is a 21 square. So the BD is 21. Since we are looking for 3/11th of this because of the BF is 3x, so 3/11th of 21 is actually 61 over 11. Okay, so that wasn't too bad, but at first it might be looking a bit confusing, but I think log cosine is always something we want to use, especially with the 12 problems. So this was number 8. Anyway, I'll see you in the next video.